Hello coders, welcome to my channel. I am Aniket and today we will discuss question from GFG, that is substring with more ones than zeros. So let's read the problem. Given a binary string S consisting of zeros and ones, calculate the number of substring that have more ones than zeros. So if you consider this string and generate all of its substrings, so what are the substrings from this string? So first substring is 0, second substring is 0 1, then 0 1 1, then another substring is 1, then 1 1, and the last substring is only 1. So there are total 3 plus 2 plus 1, that is 6 substring. So out of these three substrings, what are the number of substrings where number of ones is greater than zeros? So here it is not, but here it is, because there are two ones and one zeros. So here number of ones is greater than zeros. Similarly here also, and similarly here also. So that's why there are four substrings which have this condition, such that number of ones is more than number of zeros. So that's why the answer to this problem is 4. I hope you understand the problem now. Let's jump to the solution. Now let's discuss the brute force method. So the brute force method is very simple. The first step is generate all substrings, as I do before also. I will generate all substrings and calculate the number of zeros and ones, and if in that substring and if in that substring you found that number of ones is greater than number of zeros, so increment your answer. This is very simple approach, but what is the complexity of this approach? For generation of all substring you have to do n square loop, and that's why the complexity for this approach is O of n square. So it will easily give you TLE. So we have to think a good approach now. This brute force approach will not acceptable in our question, because the string length can ranges up to 10 raised to the power 4, so it is not acceptable. We have to think a more optimal approach. So let's discuss some observation from this problem. Let's say you have a string like 0 1 1 0 1 0 0 1 0 1. So if you convert this string into +1 for 1 and -1 for 0, so what is the string now? So +1, this is -1, this is +1, this is 1. So every 0 is converted to -1 and 1 remain as it is. So this is the conversion string. Now what happen if I do a prefix sum array, pre-sum array from this string? So the prefix sum array, let's make it an array for this string. So -1, the first element is -1, then +1, now it becomes 0, then +1, now it becomes 1, then -1, now it becomes 0, then 1, then 1, and then -1 0, 0 -1 -1, -1 +1 0, and 0 -1 -1, and -1 +1 0. Now I can surely say that when pre-sum of I is greater than 0, so what does it mean? So it means the substring from 0 till I is a valid one. Valid. So what is the validity? Number of zeros, number of ones is greater than number of zeros. So from this prefix sum array, we can surely say that if prefix pre-sum of I is greater than 0, so it means the substring from 0 to I is a valid. So let's see this. We see that here pre-sum of I is greater than 0. So if you consider a substring 0 till I, that is this. If you consider a substring 0 till I, that is this, so you will find that your substring containing number of ones is greater than number of zeros. So that's why this substring is a valid substring. So let's say here also you have pre-sum I is greater than 0. So if you consider this substring, also, so you will find that number of 1 is greater than number of zeros. So I hope you understand it. But our substring is not always start from 0 only. We have to count other substring also. Let's say if you want to see this substring whether it is valid or not, so if you do it manually, then you will find that number of ones is greater than number of zeros. But how can you use this pre-sum array such that you will easily find that this substring is a valid one? So to find this string whether it is valid or not, we have to know what is the meaning of pre-sum of I. So what is the meaning of pre-sum I? Pre-sum I means number of number of ones minus number of zeros simply. So pre-sum I means the number of ones minus number of zeros in the substring 0 till I. But how can you generalize it for any mid substring like this? So it is very easy to generalize. So let's say pre-sum I, here let's indexing it 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So here pre-sum of 4 is nothing but 3. So that's why the number of ones minus number of zeros is 1. So number of ones is 3 and number of ones is 3 and number of zeros is 2. So that's why pre-sum of 4 is 1. And I populate it in my array also. So here it is 1. So pre-sum of 4 this representing this substring. So what happen if you do pre-sum of only 0? So pre-sum of 0 representing only this substring. So if you subtract both of them, so pre-sum of 0 is -1. So if you subtract both of them, pre-sum of 4 minus pre-sum of 0, you will find that answer of substring ranges from 1 to 4, whether it is valid or not, whether it is valid or not, because it is giving you the number of ones minus number of zeros in that substring only. So if you do 1 minus -1, so you will find that the answer to this substring is 2. So 1 minus -1, the answer to this substring is 2. So here also the answer of this substring is also 2, because here number of ones is 3 and number of zeros is 1. So if you do 3 minus 1, you will find that the number of 1 is 2 more than number of zeros. Let's generalize this formula for any substring from L to R, any substring from L to R. So you have to do pre-sum of R minus pre-sum of L minus 1, which will give you the number of 1 minus number of zeros in the substring from L to R. I hope you understand this formula. So for validity of this condition, for validity of this substring L to R, this quantity should be greater than 0. So pre-sum of R minus pre-sum of L minus 1 should be greater than 0. Otherwise this string is not valid for us. So if it is greater than 0, so pre-sum of R is greater than pre-sum of L minus 1. So this is a very important observation to get our optimal solution. So what does it mean? It means that for any pair I comma j where I is less than j, if you found that pre-sum of I is less than pre-sum of j, then the substring from I to j is valid substring. That is number of ones is greater than number of zeros. Now our problem simplifies to problem becomes count the number of such I comma j pairs where you will found that pre-sum of I is less than pre-sum of j, and you have to do it in O of n time only, not doing it in O of n square. Now the question arises that how can we find the number of such pairs in efficient way. Let's say we have an pre-sum array like this. We have an pre-sum array. So first element is -1, then 0, then 1, then 2, then 1, then 0, then -1, then -2, then -1. So this is our pre-sum array. An important thing to note here is pre-sum of I and and pre-sum of I plus 1 difference is always equal to 1 only, because you add 1 when you see a 1, and you decrease by 1 if you see a 0. So that's why the difference between two adjacent pre-sum I and pre-sum I plus 1 is only 1 only. Now let's say you traverse from here. So if you traverse this -1, what is the number of indices which is lesser than it? To calculate that, we will initialize a variable called left, which is denoting the number of pairs I comma j of substring ending at j index. So here the left will be 0 initially, and there is a dummy node at initial, that is 0. So to check that this substring is valid, so let's say you take this substring 1. So if you find that what are the number of strings which is lesser than it, so there is 0 and -1 is lesser than it in the left side, and this 0 also is less than it, so that's why there is 3 substring which are ending at this position. So there are 3 substring which are ending at this position, which is valid one. So that's why we have to take this 0 as dummy node, so that we can check the validity of a substring which starts from 0 till I. And we have to initialize a map also to store the map of int comma int to store the frequency of pre sum I. So initially it is dummy node, so that's why we have to put map of 0 comma 1. This first uh, this first int will denote the key, that is the pre-sum I, and this second int will denote the frequency, that is the number of occurring this value pre-sum I. Now you are at 0th index and you will find that left is 0. So if you carefully see, is there any index in left side such that it is lesser than this -1? So the answer to this question is no. So that's why you will not increment your left, but your map will do -1 comma 1, which means -1 is seen only one time, and the 0th index, the pre-sum is -1. Let's move to the next index. So if you move to this 0th index, so what is the value of left now? And if you see, your pre-sum is increasing. So there are two cases. Two cases. What are those? Pre-sum increases, and the second case is pre-sum decreases. So if the pre-sum is increases, so you calculate left before increment of that pre-sum. So you have to do left plus equal to map dot get pre-sum of I, pre-sum of I. This will give you those indices, those values which are lesser than it. After that only you will go to I plus plus, next index. But if the pre-sum is decreases, so you will increment your left by, so in this case you will go to the next index, then you will decrement your left by map.get of pre-sum of I. Now let's see this with an example. So here, if you consider this 0, so the pre-sum is increases. So this is this case. So if the pre-sum is increases, you will increment your left by plus equal to map.get of this previous one before increment of index. So map.get of -1 is 1. So your left will become 1 now. And you will find that there is only one index which is in the left side of this index which is lesser than it. So that's why left will become 1. Now you will increment the frequency of this 0 now in the map. So now your map will become 0 comma 2 now. Now if you carefully see, you will go to the next index. Here also the case is increasing, pre-sum is increases. So that's why you have to add this 0 into your left. So if you add the frequency of this 0, map.get of 0, you will get 2, and then you will increases your index to to this 1. So what is the meaning of left? Left meaning that number of pair I comma j of substring ending at j index. So there are 3 pairs which is valid one. So for this one, there is this index, and this index which is lesser than this one. So that's why this left will store the correct value. Now in the next case also the pre-sum is increases. So that's why you have to increment your left from map.get of this one, that is. So after doing this you have to update your frequency of 1 also. So you have to increment map.get of 1, that is 1, and then you will increment your I++. So that's why there are 4 indices which is lesser than this 2, 1, 0, -1, 0 in the left side. So that's why this left will store the correct value. And after doing this, in every iteration you will increment your answer by left, and in this way you will calculate your answer correctly. Now if you consider this case, now the pre-sum is decreases. So this is this case. So pre-sum is decreases, you will go to the next index, then you will perform left minus equal to map.get of pre-sum I. So you will go to the next index, but before that you will put map of 2 comma 1, and after going to the next index you will decrement the map.get of 1 into your answer. So map.get of 1 is 1, that's why you will decrement it your from your left. So now there are 3 indices which is lesser than it in the left side. So that's let's see this. For this one, 0, -1 and 0 is the number of indices which is lesser than this one. So that's why our left will store the correct result. Now in next case also your pre-sum is decreases, so that's why you will decrement this one value from your map. But before that you will update your map also, so that's why you will decrement your value of this one. So before going to the next index, after going to the next index you will decrement the value of this one, the value of this 0. So what is the map.get of 0? Map.get of 0 is 2. So that's why you will decrement this from your left. So there are now only one element which is lesser than this 0. That is nothing but this -1. So that's why our left will store the correct result. Now in the next case again pre-sum is decreases 0 to -1. So first of all we have to do update our 0 frequency. Now in next case pre-sum is decreases 0 to -1. So this is this case. So you will go to the -1 and decreases the frequency of -1. So we will go to the -1 and decreases our frequency of -1. -1 frequency is 1. So that's why there is no any element which is lesser than this -1. And you can easily see this in this pre-sum array, that is 0, 1, 2, 1, 0, -1, 0. So every element is greater than equal to this -1. Not any of these element is lesser than -1. I hope you understand this. And now if you carefully see here also, but before that you will update the frequency of this -1. Now here also the pre-sum is decreases. So that's why this is this case. So you will go to the next index I++ and you will decrement the value of this, decrement of the frequency of this -2. Since the -2 is not present, so you will decrement only 0. Now you will update the map to -2, 1. So there are 0 element in the left side which is lesser than this -2. So that's why our left will store the correct information. Now in the next case your -1 is increases. So this is this case. -2 to -1 is increase case. So you have to do left plus equal to map.get of pre-sum I before increment of index. So you will do map.get of -2, that is +1, and then you will increment your index. Now there is only one index which is lesser than this -1, that is nothing but -2. So that's why our left will store the +1 only. Now in the next time the loop will out of the array, and that's why our answer will store the correct result. So our answer stores the number of pairs I comma j which has this property, which has valid substring. I hope you understand the dry run. Let's jump to the code. But before that, please hit the like and subscribe button, because it takes lots of effort to create such kind of intuitive video for you. So please hit the like and subscribe button. And here is my simple Java code for this problem. So the answer is storing the final answer, and the pre is storing the prefix sum I. So pre is the replacement of pre sum of I, and this left is storing the number of substring, number of valid substring ending at I. So I hope you understand these three terms. Now this map is used to store the frequency of every pre sum I, and initially there is a dummy node which is 0, so that's why we will put map dot put 0 comma 1, that is the frequency of the 0 is 1. Now you will process your string from 0 to n, and if you found a one character, then you will there is a case of increment, so that's why you have to do left plus equal to map dot get dot default pre comma 0, then you have to do pre plus plus, and in the decreasing case you have to do pre minus minus first, then you have to do left minus equal to map dot get dot default pre comma 0, and in this way the left will store the correct value of number of valid substrings ending at I, and after that you will increment your answer by this left amount, and before that you will put the pre sum I into your map, and update that frequency, and in this way you will find your answer as correct answer. I hope you understand my code and the intuition behind this code. Please hit the like and subscribe button so that it will motivate me to create such kind of intuitive video for you. I regularly make such kind of POTD discussions for you. Thank you for watching my video.